Hello everyone, welcome to this lecture on communication systems. Communication technologies have transformed the way people interact, exchange information, conduct business, and access services. From cordless phones and fax machines to smartphones and tablets, communication systems have evolved tremendously over the years. In this lecture, we will study the evolution of communication devices and understand the working principles behind some of the most commonly used communication technologies. A cordless telephone is essentially a combination of a conventional telephone and a wireless radio communication system. It consists of two major components, namely the basic unit or base unit and the handset. The base station is connected to the telephone network through a standard telephone jack. When an incoming call arrives, the electrical signal received from the telephone line is converted into a radio frequency signal. This radio signal is then transmitted wirelessly to the handset. The cordless phone provides mobility within a limited range without requiring physical wiring between the user and the base station. This convenience made cordless phones extremely popular before the widespread adoption of mobile phones. This diagram illustrates the architectural functional arrangement of a cordless telephone system. Observe that communication takes place through radio frequency signals between the handset and base station. The base station acts as an interface between the public telephone network and the wireless handset. This arrangement allows user to move freely and also users to move freely within the coverage area while maintaining communication. The base station continuously handles signal conversion and transmission between wired and wireless domains. Let us now understand the operation of a cordless phone. When a call is received, the base station obtains the incoming signal, that is electrical signal, from the telephone network. This signal is converted into an FM radio signal and transmitted to the headset. This handset or headset receives the radio signal and converts it back into an electrical signal that drives the speaker. Similarly, when a speaker is driven, when a user speaks into the handset microphone, the voice is converted into electrical signals. These signals are transmitted wirelessly back to the base station using another radio frequency channel. The base station converts the received signal into a telephone line signal and forwards it to the other party. This two-way communication allows full duplex conversation. Cordless telephone technology evolved through several generations. The first generation, called CT1, had an operating range of approximately 100 meters. It used frequencies between 1.6 and 1.8 MHz for the base station and around 47 MHz for the handset. The second generation, known as CT2, operated between 864.1 and 868.1 MHz and introduced improved communication techniques based on TDMA. The third generation evolved into DECT technology, operating in the 1880 to 1900 MHz range. DECT provided enhanced voice quality, better security, higher capacity, and features similar to cellular systems such as GSM. These developments significantly improved cordless communication performance and reliability. Before the availability of an email and internet-based document sharing, fax machines were among the most important office communication devices. The term fax stands for facsimile automatic xerox. A fax machine scans a document and converts its graphical content into electrical signals. These signals are transmitted through telephone lines to another fax machine located elsewhere. At the receiving end, the transmitted signals are converted back into graphical information and printed on paper. Thus, the fax machine enabled long distance transmission of documents without requiring physical transportation. These figures illustrate the construction, structure, and operation of a fax machine. The entire process involves document scanning, signal conversion, transmission through the telephone network, reception, reconstruction, and reprinting. For many years, fax technology was widely used in government offices, businesses, legal institutions, healthcare facilities, and banking systems because it provided rapid document exchange capabilities. The fax scanner contains a rotating cylinder, a light source, and a photoelectric sensor. The document is wrapped around the rotating cylinder. As the cylinder rotates, a light beam scans the document line by line. Reflected light intensity varies according to the printed content on the document. A photoelectric sensor converts these variations into electrical signals. These generated signals are amplified and transmitted through telephone lines. At the receiving side, a similar mechanism reconstructs the document by reproducing the original pattern on paper. This process enables accurate reproduction of text and graphics over long distances. The smartphone represents one of the most influential communication technologies in modern society. A smartphone is essentially a mobile phone integrated with advanced computing capabilities and internet connectivity, multimedia functions, and intelligence software. Besides voice communication, smartphones serve as cameras, entertainment devices, navigation systems, internet terminals, and productivity tools. Today, smartphones have become indispensable devices supporting communication, education, healthcare, banking, social networking, e-commerce, and countless other applications. The smartphone integrates numerous electronic subsystems into a compact device. These include processors, memory, displays, wireless communication modules, cameras, sensors, batteries, and software platforms. Advances in semiconductor technology have enabled tremendous processing power to be packed into small handheld devices, making smartphones comparable to personal computers in many applications. A smartphone consists of several major subsystems. The processor subsystem coordinates all operations within the phone. The RF subsystem provides wireless communication capabilities through antennas and modem circuits. The display subsystem provides visual output. The peripheral subsystem includes cameras, audio devices, GPS systems, and other external interfaces. The power management subsystem is responsible for charging, battery management, and power distribution. These subsystems work together to create a complete mobile computing platform. One of the most visible components of a smartphone is its display. Modern smartphones primarily use two display technologies. The first is LCD technology, particularly IPS variants that provide excellent color accuracy and viewing angles. The second is AMOLED and Super AMOLED technology, which offer high contrast, deeper blacks, lower power consumption, and superior image quality. Display technology plays a crucial role in user experience, multimedia consumption, and battery performance. The system on chip, commonly called as SoC, is the heart of a smartphone. The SoC integrates the CPU, GPU, modem, display controller, image processors, and many other functional blocks on a single semiconductor chip. This integration reduces power consumption, saves space, improves performance, and lowers manufacturing costs. Without the SoC, modern compact smartphones would not be possible. Smartphones rely heavily on memory and storage resources. RAM provides temporary working space for applications, while internal storage permanently stores software and user data. Communication modems handle text messaging, voice communication, and internet connectivity. The camera systems consist of the image sensor, optical lens, and image processor. Together, these components capture and process high quality photographs and videos. Modern smartphone photography has advanced significantly due to improvements in sensors and computational imaging techniques. Smartphones contain a variety of sensors. The accelerometer detects motion and orientation. The gyroscope detects or measures rotational movement. The digital compass identifies geographical direction. The ambient light sensor adjusts display brightness automatically. The proximity sensor disables the touchscreen and during calls when the phone is close to the user's ear. These sensors enable intelligent operation, enhanced usability, and context-aware applications. A tablet is a portable electronic device that bridges the gap between a smartphone and a laptop computer. Tablets support multimedia playback, internet browsing, gaming, document creation, email communication, and social networking. They typically provide network connectivity through Wi Fi and sometimes cellular networks. Modern tablets incorporate sensors such as GPS receivers and accelerometers with the availability of high speed 4G and 5G networks. Tablets have become more powerful platforms for education, entertainment, business applications, and home automation control. Improvements in artificial intelligence and voice recognition further enhance their capabilities. This slide shows a typical tablet device. Despite similarities with smartphones, tablets generally provide larger displays, improved battery life, and enhanced multimedia experiences. They are widely used for online learning, digital publishing, healthcare applications, professional presentations, and remote communication. The continuous advancement of wireless communication technologies ensures that tablets remain important devices within the modern communication ecosystem. Next, we'll see about the smartwatch. So before that, we will quickly have a summary of what we have studied so far. We studied cordless telephones, fax machines, smartphones, and tablets. We examined their architecture, operation, major components, and significance in modern communication systems. So in the next part of this lecture, we will explore smartwatches, video conferencing systems, web cameras, and IP cameras. So let us begin with smartwatch. A smartwatch is a wearable computing device designed in the form of a wristwatch. Unlike traditional watches that only display time, smartwatches provide advanced features similar to those found in smartphones. These include communication capabilities, fitness monitoring, health tracking, notifications, internet connectivity, and multimedia functions. Modern smartwatches contain touchscreens that allow users to interact directly with various applications. They are often connected to smartphones using Bluetooth or Wi-Fi and can synchronize information such as messages, calls, emails, reminders, and calendar events. Smartwatches are becoming increasingly important in healthcare because they provide continuous monitoring of vital physiological parameters. This allows users to track their health in real time and supports preventive healthcare initiatives. This figure illustrates a typical smartwatch. Although compact in size, a smartwatch contains highly sophisticated electronic components including processors, sensors, displays, batteries, communication modules, and operating systems. The continuous advancement of microelectronics has enabled powerful computing platforms to be integrated into wearable devices. Today, smartwatches are widely used for fitness tracking, health monitoring, navigation, communication, mobile payments, entertainment, smart home control. As a result, they have evolved beyond simple accessories and become important components of Internet of Things ecosystems. So one of the most important aspects of smartwatch is its sensing capability. We have biosensors. These are blood pressure, EMG, ECG, glucose, brain waves, and temperature sensors. And environmental sensors. Examples of these sensors are ultraviolet, ambient light, pH, gas, pressure, and dust particles. Motion sensors. These are gyroscope, acceleration, atmospheric pressure, and geomagnetic sensors. Let us now study the major hardware components of a smartwatch. The wireless chipset is one of the most important component. It enables communication through GPS, Bluetooth, Wi-Fi, and NFC technologies. Since smartwatches are small devices, these chipsets must also be compact and energy efficient. The display is another crucial component. Common display technologies include OLED, E-Ink, LCD, and Sharp Memory LCD displays. OLED displays are particularly popular because they offer high brightness, excellent contrast, and low power consumption. The battery is typically based on lithium-ion or lithium polymer technology. Efficient battery management ensures longer operating life between charges. Finally, the processor performs computational tasks. Most smartwatches use ARM-based processors because they provide excellent performance with low power consumption. Together, these components enable smartwatches to function as a powerful wearable computers. Let us now move to the video conferencing systems. Video conferencing is a communication technology that allows individuals located in different geographical areas to communicate face-to-face without meeting physically. Video conferencing has become extremely important in education, business, healthcare, government administration, and remote work environments. Organizations use video conferencing for team meetings, project discussions, job interviews, client interactions, training sessions, online education. The main advantage of video conferencing is that it eliminates the need for travel while maintaining effective communication. During recent years, video conferencing platforms have become essential tools supporting global collaboration and digital transformation. Components of video conferencing system. Video input is used to capture live video of participants and convert visual information into digital data. And microphones is an example for audio input. Captures voice signals and convert them into electrical signals suitable for digital processing. The third component is processing unit. The processing system compares audio and video data, converts them into packets, and prepares for transmission. The fourth component is transmission medium. This can be internet, broadband networks, or telecommunication systems through which data is transmitted. Finally, output devices such as monitors, displays, speakers reproduce video and audio information for the participants. These are all some of the classifications of video conferencing systems: standalone dedicated systems and desktop systems. The architecture of a video conferencing system can be viewed as a layered structure. The first layer is the user interface layer. It provides a connection between users and the underlying communication infrastructure. The second layer is the conference control layer. This layer manages resources, packet routing, conference scheduling, and control functions. The third layer is signaling plane. Protocols such as H.323 and SIP operate at this layer and establish communication sessions between participants. The fourth layer is the media plane. Protocols including UDP, RTP, RTCP manage the actual transmission of audio and video streams between users. Together, these layers ensures smooth communication and efficient multimedia transfer. So these are all some of the advantages of video conferencing. There is no time constraint, dramatic travel saving, easy communication. These are all some of the disadvantages: lack of personal interaction, technical problems, international time zones, high cost of setup. So that's all about video conferencing. We will see about web camera, IP camera in the upcoming lecture. So thank you for watching this lecture.